So welcome everyone to this week's edition of the Micro-school. My name is Dean Brand. I'm a PhD student at Stellenbosch University and part of NITheCS. Yes, this Micro-school is on an introduction to Xarray as a Python package, and our speaker today will talk more about the details of it. I'd like to welcome the speaker, who is Marco Wolsza, who is a visiting PhD student at Stellenbosch University. He's originally from the Department of Earth Observation at the Friedrich Schiller University in Jena, Germany. He's an affiliate researcher at the Mathematical Biosciences Lab here at Stellenbosch University, where he's co-supervised by Dr. Sandra McFadden, who's part of the audience today. His research focuses on modeling vegetation structure in savanna ecosystems using Earth observation data, applying data engineering, statistical modeling, and machine learning techniques. So he's a very good person to be learning about Python packages for working with data and numbers from. So with that, I'd like to hand over to Marco to please take it away.
So thank you very much for the introduction. So I'll just share my screen. And also, yeah, so as also other micro-schools have done it, we will go through a Colab notebook, and I can also share the link in the chat. So when you, I will share the link to the GitHub repository, and when you click here on the link, you will go directly to Colab. Or if you click on the notebook here, it will have a button on the top, kind of similar to how it has been done in other micro-schools. So where can I? There's the chat. Oh, there's the chat. Okay. So here we are. Yeah, but I will go through it, and let's see how much of the material we can go through now. But I've created the notebook in a way that you can also look into it afterwards, and there's a lot of like descriptions and links to further to parts of the documentation, for example, that will help you understand it without me talking about it. So yeah, Xarray is empowering multidimensional data analysis. And then very short, like a summary is that it makes working with labeled multidimensional arrays in Python simple, efficient, and fun. Oops, didn't do that. And it extends NumPy and Pandas. So the micro-schools of about NumPy and Pandas are quite relevant. Yeah, you will see how this extension works in just a few minutes. So it extends NumPy, for example, by adding labeled dimensions, coordinates, and attributes. So first off, yeah, the quite up-to-date version of Xarray is already included in Colab, so we don't need to install anything. This is just a way here with NumPy, Pandas, and Xarray how to abbreviate the importing of these packages, kind of a common way to do it. So to identify which functions are coming from which package, basically. So let's start with a multidimensional array in NumPy, not yet in Xarray. So this is how it looks like. In this case, we have 3 dimensions. One is 1460. The others are 50 by 50. So yeah, this, for example, would be a 50 by 50 array. And then we have another one and so on. So yeah, you can think about it as like a stacked multidimensional array. These are just random values. And just to verify, this is the shape of the array. And if we think about real-world data, this could be, for example, air temperature measurements. And the dimensions could correspond, for example, to time and to spatial dimensions, latitude and longitude. So this is yeah, how you can think about this array. In NumPy, if you want to, for example, select the 100th time step, you would do it here using positional indexing. So if you have watched the other micro-school, you will recognize this. And yeah, you need to know which dimension is representing what. We can also calculate, for example, the mean of each latitude longitude grid cell, and you will get an output like that, and it looks quite right. But actually, so what I wanted to show here is that this is actually not true. So we have here selected the wrong axis in order to calculate the mean of each grid cell, because we have here still the temporal dimension. So in order to do it in the right way, we would select the Python is starting with 0, so we use this axis to actually calculate the latitude, longitude mean per grid cell. So this is how it looks like, and you can understand, like, okay, if you have like a more complex multidimensional array or multiple of them, and you create some kind of complex workflow, then it's quite error prone. And especially if you then maybe come back to your code some weeks or month afterwards and you have not really included useful comments, then yeah, it's a little bit difficult to understand what you wanted to do there. So now we are loading an Xarray data set. So this is kind of the same what we have now seen, but an actual data set. So it's actual air temperature measurements. And this is how it looks like in Xarray. So immediately we see here like a representation of this data set. We have the latitude and longitude dimensions, the time dimension, and we can even click here on these. It's kind of interactive in the notebooks, so you can click on these buttons and you see that there's actual values for latitude and longitude, for example. And also the time dimension is made out of an array of timestamps, basically. So this is already quite useful. And inside of this data set, we have here the actual air temperature measurements as the data variable. And this is kind of showing you the core data structures of Xarray. So we have this data set, and inside this data set, we have a data array, in this case, air. We could have here even more data arrays that are sharing these dimensions. So for example, if we have also one that's called precipitation, for example, or different levels of air temperature for different, or air pressure, for example. So this would make a comprehensive like data set, and we can use this for the analysis. So for the next steps, we are just going to use this air data array that is included here, because we don't have any other data arrays anyway. So I'm just saving this in a different variable. You can access this by using dot notation, or here in dictionary syntax, for example. And as you can see here now, this is actually here a data array, fixed array, and inside we have the multidimensional NumPy array, basically. And the coordinates is providing us additional information. And just to show you that inside of this data array is actually a NumPy array. So these packages are really closely interlinked. Basically, we can here use this dot data. It will show you that this is a NumPy array, just to verify the type of this data set is a NumPy array. So I have also included here some like bonus parts, so you can look into that later if you want. For example, how to create this data set, Xarray data set by scratch, more or less, with random data. So this is kind of helpful to understand with Python programming how you would create a data set like that. Most of the times you're using some kind of real world data, and you would import this data set into Xarray, and you would have already the data structure. So not in that many cases, or at least in my work, I have not really created manually data sets myself, but it might be useful. So the next part is about how to select and index the data using Xarray, and you can see hopefully here also the benefits of using Xarray. So first off, again, these are the dimensions. So they have names, time, latitude, and longitude. And again, how you would select the 100th time step with NumPy positional indexing. You would do it in this way. This also works here with the Xarray data array. So But in this case, in comparison to earlier, we now see actually that it worked, and we have now only the latitude and longitude dimensions, for example. But because we have names for the dimensions, Xarray can actually use this information, and here we have an Xarray way of selecting this time step by saying, okay, in this case it is iCell, so integer select method, and we tell it, okay, which dimension do we want to select, and yeah, here the 100th number. So this is already much more clear in the way this code is written. So you can later also much easier understand what this means. And another way of selecting data is, for example, through the labels of the dimension. So I have shown earlier that the time dimension is made up of an array of time steps, and you can use this information to select time steps. In this case, this is also the 100th time step, but what we have done here is only selected a day, and because the day the data set is has a sampling of 6 hours, so we actually for this day we have 4 different time steps. So we can also see that here quite easily, and we can show this in the next cell. We can also here provide also the hour and minute and so on to go more into detail and select a specific time step, for example. There's also even more possible, but we don't have that much time, so just showing the basics. Something a little bit more advanced is, for example, that we can select also using like Boolean masking, for example, all of the values that are above 250 in this case. So as you can see, it immediately selected all values that are above 250, and all other ones automatically set to none, or not a number. So it's quite useful, and you can create quite easily very complex ways of masking this multidimensional array and select only the data you want, for example, for a next step in your analysis. So it's quite powerful. Yeah, so exactly, maybe we have a little bit more time, so I can just show you quickly that we can also, yeah, this is maybe interesting now to show as well, that Xarray in this case here with the time dimension borrows a lot from Pandas, for example. So you can actually also select, use this .dt accessor, and it makes it possible to select, for example, only time steps that were taken at 6 p.m., for example. So this is really showing how interconnected Xarray is with NumPy and Pandas. Yeah, but you can look into this on your own if you want to learn more. Now with the computation, yeah, at this point you can receive Happy Pi Day. In the NumPy Micro-school, it was also mentioned that something like vectorization exists. So we don't have to, in this case, we are subtracting 273.15 from all values in this data array. And we don't need to do this in a way, for example, with a for loop or something like that. So we can just do this immediately on the whole array. And this is called vectorization. So this also, of course, works here in Xarray. And this is actually, you maybe have noticed the values are like 200 something. So this doesn't mean that this data set is showing the end of the world where climate change has resulted in 250 degrees Celsius. This was actually values in Kelvin, and this is calculating the Celsius values. Yes, so we can also, of course, use any other, a lot of different already integrated methods for calculating, for example, the mean of the data quite quickly. We can also use NumPy functions directly on these Xarray data arrays or data sets. So here I'm actually addressing the latitude dimension and converting it from degrees to radian. So you can see how, you can integrate also other related packages into your workflow. Maybe some of these functions are not available in Xarray, but in other related packages. Also SciPy, for example, is quite related, and I think you can use a lot of the functions directly also on Xarray. So here, especially with time series analysis, there's a lot of like aggregation methods. For example, if you want to calculate the mean per month, you can do it in a way shown here. So we are selecting, in this case, the data from 2013 in January, and then the other line here from February. And we're using then the integrated mean calculation. And we can tell it to calculate the mean over the time dimension. So this is how, quite convenient in Xarray that you can address the names of the dimensions to do what you want to do. So in this case, the mean per month. You can do this now here manually for each month, but it's also possible to do it much easier and like in one go to do it for the whole data array. So for example, here we are resampling the time dimension to monthly data. So this results in like different groups. So each group is the data for 1 month. And we can chain these operations together. And here we'll then for each group calculate the mean. And this results in a new data array. As you can see here, it now has only 24 time steps. So the whole data set was for 2 years. So 2 times 12. And so this works. And this is quite also showing how handy this representation is, that you immediately see, this actually worked. And I'm expecting this calculation to result in 24 time steps, and this actually worked. So this is, for me, also quite helpful sometimes to understand if what I want to do is working. So there's also more powerful concepts that I'm not showing here. For example, group by operations, where you can group by some attribute and then apply also computation. And this is a little bit more advanced. So lastly, showing something about the visualization. So here we can easily use this dot plot method. So this is integrated in Xarray. And here in this case, we are selecting 1 point, so like the latitude 10 and longitude 10, and just plotting the time series of this grid cell, basically. So again, here we are kind of chaining 2 methods together and just plotting it with this plot method. And as you can see, it kind of understands what I want to do and just plots a line plot. So this is actually what I wanted to do. But you can also, the plot method is connected to some other methods. So you can click here on the documentation, you will see there's some different options. And you can also be a little bit more specific. So I like to usually be more specific and actually say, okay, I want to have a line plot. Because sometimes maybe the results are not as expected. And you maybe also recognize, if you have seen the Matplotlib micro-school, that this type of plot is kind of familiar, because Xarray is basically wrapping the Matplotlib methods and using it for their own plotting. And this is also making it possible to kind of change the plot by using the Matplotlib package, actually. So here I'm importing it, and I am, in this case here, I'm kind of plotting the same. Here I'm a little bit more specific by using the line plot, and I'm providing some arguments that are, I think, directly coming from Matplotlib. And I can also here actually customize this plot by using Matplotlib, and you see that it's changed. We changed here the line width, the color, and so on, and some other things. So this is also quite handy. But there's also other ways to plot. I will show it later. Also here, just showing you that this is actually spatial data. So if we select the 100th time step again and plot it, it here understands immediately, this is actually spatial. And you see here some patterns. You can kind of make out that it's North America with some imagination. This is showing another way of plotting. Well, it's kind of the same way of plotting, but you can see that I can also give it a column. So in this case, the time dimension, and it will just plot all of the time steps next to each other. So it's also quite cool. Yes, and just maybe very shortly showing you some advanced ways of plotting. So this is verifying that it's actually North America. You can plot this map also on the globe. And also I've also mentioned that this whole ecosystem is quite rich. You have a lot of packages working kind of together, and also the visualization aspect. There's a lot of other packages that go beyond just these Matplotlib visualizations. And here in this example with HPplot, you can quite easily create interactive plots. So this is also quite quite cool, I would say. So this whole ecosystem is quite rich. And I've provided here also 2 additional resources if you want to go beyond this introduction. For example, here in Xarray in 45 minutes instead of 23 minutes. And this is kind of it from my side. There are some questions.
Yeah, thank you very much, Marco. It was very interesting to see how to use this package and how well it fits into everything else. So there was one question in the chat with a bit of code. So I think if you want to have a look and see exactly what's being asked.
Yeah. Right. Can you plot the resample data? Can you plot the resample data also as air resample? Sandra, I can just try. I'm not sure exactly. Wait. So this was just so what I had earlier. But, here. Okay. So it works. Works. So also with the group data, I think here in the documentation about plotting, it shows also quite in this direction other examples of how to create different types of plots using group data or resample data and so on.
Great, thanks. Are there any other questions from the online participants? Here's another one in the chat.
If I have a data cube in a CSV format, how can I read it into an Xarray format? Let's see in the documentation. Just going very quickly. So there's like yeah, as I maybe I didn't mention, the documentation is quite good and very extensive. It has a lot of information. Also, this is a good point on importing data that I have not talked about. Where do we have it? Import. I think it also supports. Oh no, this is wrong. It also supports CSV, but I'm not exactly sure. Here, reading and writing files. A quite common data format is NetCDF actually, because this package or project came, I think, about from oceanography and so on. So they're using a lot of NetCDF, which is just a format to store multidimensional arrays. Here, CSV. So it's also possible to import tabular data as well. And because it's also quite interlinked with Pandas, I think you can also just export to Pandas, or I think also convert a Pandas data frame to an Xarray if you have the spatial dimension as well, or not even if you. I think even if you don't have the spatial information, you can also import it. Are there good practices on the metadata associated? I'm not sure what exactly you mean by the metadata. I mean, I guess it depends on the application. So let's go back to where I'm importing this data set. So here. Here. Yeah, here you see some attributes that are already included in this data set. I guess you are free on what you want to include. It depends. I mean, there's no guidelines from Xarray side because every domain has its different requirements, for example. But yeah, you can include quite a lot of attributes as well. And in some cases, I've, for example, worked with satellite data cubes where there's a lot of information included that you can then also directly use in your analysis. So you can actually use the metadata in order to, for example, filter this data cube as well. So this is also quite can be quite useful if you include the useful metadata as well. And Sandra has one question again. Are there online data sources like Google Earth Engine or Digital Earth Africa where you can access data directly in Xarray format? Yes. I will. So the plan is actually to do another micro-school in 2 weeks' time, where I'm actually talking exactly about this topic, where you can use like openly available satellite or Earth observation data sets to directly load them into Xarray, for example. But if you search for Digital Africa sandbox or documentation, you will find a lot of notebooks as well. And they have also some information about introductions also to Xarray, for example. Google Earth Engine, I think they have also, maybe I will search for it, Google Xarray. I think they had like another package here. It's like an Xarray extension for Google Earth Engine.
Yeah, very interesting. Thank you, Marco. I see there's one last question about, are there any good practices on the metadata associated?
I already talked about that. So
Oh, okay. Sorry.
yeah.
Missed that. I thought it was part of a different answer. Okay. So yeah, I think that's probably all the questions that we have for now, and we've perfectly timed it to fill out the half-an-hour gap. So I hope that everyone had a good time and look forward to, as Marco referenced, there is another micro school following up on this coming up soon, and we'll hear more about that. Yeah, in the NITheCS newsletter or on the website. Otherwise, thank you again, Marco. I hope you enjoyed. I hope the audience enjoyed. And if you missed any part of this, it will be uploaded on YouTube on the NITheCS channel very soon. Yeah, with that, I'd like to say thank you, everyone, and have a good afternoon.
Thank you very much. Bye.
Thanks. Bye.